So when I start looking at this one and deciding what to do, one thing I note is that I have a gas in a set situation. I'm not doing anything to the gas. I'm not heating it, compressing it, or anything like that. And one way I can tell that I'm not doing anything to it is that I only have one pressure and one temperature. I'm not changing those. The other thing I notice is that I have the gas. I know what type of gas it is. And so that means that I have a molar mass. And that means I have a way to go between grams and moles. Okay, and I have a pressure, and I have a temperature. And so in a set situation, we usually want to, or we'll usually think about using the ideal gas law. It's not a mixture, so that makes this easier. I know the gas. And then if I look at this and see what do I have temperature, I have pressure, of course I have R, but I don't have volume or moles. Now moles would help me because I know that density is equal to grams over my volume, and my volume will probably be in liters. Moles, I can get, if I can get to moles here, then I could get to grams because I have the molar mass. Okay. What about volume? Is there any way to get to volume? Because if I get one of those, the V or the N, then I can use this and see where it can get me. I could maybe get that. So there's a trick to get volume, and the trick is this. If you look up here, I've drawn two boxes, and you can think about if you had a room full of air, it would work the same way. The density does not matter which box I look at. It doesn't matter if it's a big box or a little box. If it has the same temperature and pressure, it doesn't matter what volume I use. And like I said, you can think about the air in a room. The air in a room has the same density, whether you're talking about the air in the whole room or the air in a little square cubic foot or something that you might think of. So density does not vary with sample size. And anyway, so that means I can just choose a volume. And if I choose a volume, I can solve for N. And then when I come here, I would just put the volume that I chose. And I'm going to calculate, I will end up getting the mass for that volume, and I can just divide. Now, if I'm going to choose a volume, the easy thing to do is to choose 1. And I'm going to make it exact. Let's just write that it's exact. 1 liter. Okay, so now I can use my equation, PIV-NERT, and I can start plugging in. I'm going to plug in, oh, looks like my pressure needs to be changed. I need to use atmospheres. So to get this to atmospheres, I'm going to take my millimeters of mercury and divide by 760. And I'm going to carry some extra digits here. This really only has 3 sig figs, but I don't want to round off here and round off at the end also. So I'm going to do that. While I'm at it, it looks like my temperature, I need to add 273.15. And really, sig fig wise, this ends here because we're looking at how far they go to the right. The 35 goes to the ones place, and so this can go to the ones place. And notice that I gained sig figs. I went from 2 sig figs for 35, and then when I add this, I get 3 sig figs, and that's just because I'm using the add rule as I should be. Now I'm ready to start plugging into my equation that I have everything in their correct units. And then I'm going to show my algebra. I'm dividing both sides by all of this. I want to get n by itself. And of course, it cancels on this side. Over here, I need to look at my units. There's actually a K right there. When I look at my units, this K cancels with that K. This atmospheres cancels with that atmospheres. This liter cancels with that liter. And all that I'm left with is moles, and it's on the bottom of the bottom, on the denominator of the denominator, which means it's really in the numerator if I rearrange that. And sig fig wise, I really had 3 sig figs, but I'm still carrying extra digits. Okay, so I've got n, and let's remember what we were doing. We were supposed to be finding density. And density is mass over liters, but we assumed 1 liter. So now I still need to get grams, but I have moles. And so I can use the molar mass. N, remember, is moles. So I'm going to just take my moles What is this? This is helium. So just an atomic weight off the periodic table. 4 goes up here. And now finally I'm going to round off because I'm about there. I'm not going to have another step dealing with sig figs. And you can see why I used 1 for my volume. So that seems like a long process, but actually it's easier to think about than having another equation. Now there is another way to solve it using a different equation, and you could do that as long as you get the right answer. The trick to this one is assume the volume is 1 liter.